Hello, I'm Mark Pollitt, and welcome to File Allocation Table Data Recovery. In this lab, we're going to go ahead and begin with having our virtual forensic workstation up and running, and with Oracle's VirtualBox open. And we're going to go ahead and we're going to start by starting our DOS machine. Now, before I do that, I want to point out something. If you'll look down below here, you'll see under Storage, under the floppy, you will see a floppy image in there, which indicates that there's a floppy mounted. I'm going to leave that in there for a moment because I just want to show you what happens if you do that, and then show you how to fix it so that it'll boot correctly. So we'll go ahead and start our VirtualBox machine, and when it starts, you will go through the usual control key issue. Comes up with a splash screen, and then you will get, instead of starting DOS, it'll say non-system disk or disk error, replace and press any key when ready. And as I say, that means that you have a floppy disk in there that won't boot. If you did have a bootable floppy in there, it would boot, but you would come up with an A prompt instead of the C prompt. So to get rid of this error, we're going to go ahead and go to our Devices tab, and then come down here to where it says Floppy Devices, and we're going to uncheck where it says floppy.img, and when we do that and we click inside the DOS box, and we can press the space bar, and it will reboot. This time it'll say starting DOS, and we'll end up with the C prompt. So that's how we get the DOS machine working up. Now we're going to go ahead and reattach that the disk there, and again we have to hit the right control to release the mouse, and we're going to come over to the Devices, Floppy Devices, and we're going to go remount that floppy.img. Now you might have to go ahead and use the icon to search for that. It should be located in your Images folder, but just navigate to wherever it is held, and you will see it mounted. We can double check that it is mounted by going into the DOS box and typing A, and you can see that it is there. Now the next thing we're going to do in our preparation is we're going to go ahead and we're going to do a format of this. We're going to do an unconditional format that also copies over the system files to this drive. So at the C prompt, C colon, we will type the following: format A colon, and then we're going to click, type /S, which transfers the system files to it, /U for unconditional. And what that means is that it's going to overwrite whatever is on the disk, and then we'll go ahead and hit enter. It says insert a new disk for drive A. We're overwriting the one that's in there, so we'll go ahead and press enter. It goes to format it, then it asks for a volume label. In this particular case, we're going to call this lab, LAB, in caps 2 is the, no space on the, just 2, and then go ahead and hit enter. And it gives us a volume serial number. We're going to say no, we don't want another one. Just type the N and hit enter, and it brings us back to the C prompt. So now we have a DOS machine with a mounted floppy disk that is a bootable floppy disk with the system files on it. Now we're going to go ahead and we're going to go ahead and see what's on this floppy disk. So we're going to go ahead and execute the following command: dir for directory space A colon, and that will show us a single file on there. Now it looks like there's only one file on there, but there are hidden files in bootable DOS. So in order to get that, we're going to do the same directory again, dir A colon, except we're going to use the /A, which is short for attributes, and we're going to hit enter, and you can see that it now shows us the additional 3 files on there that are hidden. We're going to come back and look at those here very shortly, but that's just to show you that those hidden files are there, and they're actually you can see them in DOS. For the remainder of this lab, we're going to be using the Norton Disk Edit program, and it's a DOS program, and don't bother using your mouse because it won't work. So we'll have to use the keys, and I'll show you how to do that as we go through. So we're going to go ahead and type disk edit A:, and what that does is it starts disk edit, and it comes up here and says it's currently in read-only mode, which is fine with us right now. And it goes ahead and it brings you up to the root directory. Now this is a very specialized view of the root directory. We're used to seeing the root directory as you saw it earlier when you did the dir command, but what this does is it actually decomposes it and gives you a little bit more detail in here. So you can see the file name, the fact that it's a file, and the size of that file, the date and time that it was modified, the cluster, and we'll talk a little bit about clusters here in a little bit, and then the flags. And the flags are archived, read-only, system, hidden, directory, and volume. And you can see that in the case of our first 2 files, they are hidden files, and they're have been archived, so they're archived read-only, they're system files, and they're hidden. So that's why you couldn't see them when you did the directory listing. You could see the command com, which is merely an archive file. The drivespace.bin is likewise a system hidden file. And then the last part, the lab 2, which we created when we created this volume label, is a 0 cluster, 0 byte file, and it's archived, and it has the volume flag tagged. And you'll notice that all the other files are 531.94 and are 622 AM. That's because this is DOS version 6.22, and so all of those files will have that time indicator. And May 31st of 94 was when DOS 622 came out. So at any rate, so that's our directory entry here. Now we're going to go ahead and use some of the tools in Norton Disk Editor in order to see what's going on. We're going to hold down the Alt key and go O, which gives us the object menu, and then we're going to go down till it highlights the boot record, and we'll hit enter, and you can see that what it does is it takes the data that's written at the very top of the drive, and it parses it and tells you all of this kind of neat information: the number of clusters and sectors, the number of sizes, the byte media descriptor byte, and all these sorts of things. You'll notice also that it has the file system ID, which is FAT12, which is short for File Allocation Table, and we're just going to refer to it as FAT from here on out. In this case 12, which stands for the number of bytes that hold the data there. And then our volume label, which we created. So you can see that. Now, if you will hold the Alt key and V, right, and then just hit enter or F2, you will see what it looks like on the disk itself. And you can see on the far left, this is a hex view. The far left is the offset, so 00000000 is the very beginning of the drive, and you can see that the very first 512 characters include all these things, including that MS-DOS 5.0 label there, and the Lab 2, which you can see in here, and the FAT12. But the rest of it looks like the technical term is gobbledygook, and so you can see that. All right, we're going to go to Alt-O again, All right, and this time we're going to look at the partition table entry, which is grayed out. And the reason it's grayed out is, if you'll recall, FAT12 systems or floppy disks do not have master boot records. They have volume boot records, so there is no partition table per se. The signature for volume boot records and master boot records is hex 55AA, and so we will see if we can find that. Now, if we scroll down within the hex view of that beginning sector, that very first sector, look down at the very bottom, we will see at the very bottom the 55AA signature. See, 55AA, which represents the end of a partition table or volume boot record. In this case, it's obviously a volume boot record. We want to look at one more thing before we move along, and I want to show you a little bit about the directory entry. So we're going to go back and do Alt-O, and we're going to go to the root directory. And we're going to look at this in hex, so I can just go to F2 and it will show me this in hex. Now, if you'll notice in the hex view that each directory entry occupies the same amount of space, basically 2 lines, if you will. And that's because each directory entry is a specific format, and it occupies a specific amount of space. So we'll come back to that here in a little while, but that's an important aspect that you need to look at. Well, we're back at our DOS prompt, and we're going to go ahead and we're going to delete that file2.txt. And so the way to do that is to use the delete command, which is del/dir1 /file2.txt, and that's going to delete that file. And so if we do a dir/a:/s, all right, now we can see that it's gone. So the only thing that's left are the dot and the .dot files. All right, so if we start our disk edit again, and it brings us right back to the directory that we left, which is dir1. You can look at the directory table there, and it shows that the dot and the .dot file are still there and intact. Well, surprise, surprise, the file2.txt is exactly the same. It's there. The only difference is the very first character is this weird character which we call sigma. If we look at it in hex, it is hex E5. But in the case of Disk Editor, it shows up as a sigma, so you'll very often hear it referred to as a sigma or hex E5. So we see one change with a directory entry. And again, you look at it and you say, well, cluster 396 is where it was stored. Let's see what the file allocation tells us about cluster 396. Is cluster 396 available or not? If this is a deleted file, then it should be available. So we're going to go ahead and go Alt, and we're going to go down to FAT1 and hit Enter, and we're going to go down to 396. And 396 shows a 0, which means that it's available. Now, if we actually go to that cluster, you go Alt-O and go to cluster 396, and hit Enter, right, there's file 2. It's still there. And so what we've learned is that when a file is deleted in the file allocation table system, the only thing that changes is the first character of the file name is changed, it's overwritten, and the file allocation tables are zeroed out, showing that that space is available. And so if we want to restore that file, we reverse that process. What we would do, we don't have to do anything to cluster 396 because nothing has changed in terms of the data. All right? So we can go back to the object itself, and the first thing that we're going to do is we're going to say, all right, it's no longer merely available. It's actually occupied. And so in order to write that, we have to go over to our tools and go to configuration, which you can do the up arrow to shortcut having to go down through all that. Go to our configuration, and where it says read only, we go ahead and hit the space bar, which clears that. So now we have the ability to actually write here in the hex editor, which makes it very, very dangerous. And we just start using the tab until we get down to the save. And we'll go ahead and do save and hit OK. Now we're going to go Alt Object, and we're going to go to FAT1. And we're going to go down to 396. Tab over. And because we want that to be occupied, and we know it's only a 14-byte file, so the file is going to begin and end in that particular cluster. So we go ahead and we type in E, which will give us the end of file. All right. And we now need to make sure that the second FAT does the same thing. But diskEdit is pretty smart. So if we go Alt-O and we say, all right, we want to go to the second FAT, all right, it'll say, wait a minute, changes have been made to that sector. Do you want to update both copies? And the answer, of course, should be yes. All right, and so you just have to highlight it until you have the W, or you can just press W to do it and hit enter. It says changes have been made. Do you want to rescan the disk to make to reflect the changes that were made? And you should do that. And so we're going to go ahead and hit the R for rescan. It says, wait a minute, there's an error there. Well, the error is that we have not changed the directory entry. So now you have a deleted directory entry and a cluster that is allocated, and that's what the issue is. And if we type V, it'll say there are lost clusters found on drive A. Lost clusters are clusters that are allocated, but they're not attached to any of the directory entries. And that's true because we haven't finished doing this. So we'll hit C, hit escape for that. And we'll go Alt Object, and we're going to go to the directory now. All right, we're going to go to directory 1, and you look down here to the directory entry. And by the way, if we do F2, all right, we can see, all right, the sigma on the right-hand side, all right, here that we see in kind of English, if you will, is actually a hex E5 when you look at it in hex. So we're going to go back to our directory view of it, Alt Object and directory, and we're going to come down here, and we're going to change our sigma to a printable character, which will recover the file. Now, we don't know in theory as a forensic examiner what that character was, because once it's overwritten, it's overwritten. Now, we happen to know that it was an F because we were the ones that did it. But if we were bad guys, we wouldn't know what it used to be. And if we're examiners trying to figure out what the bad guy did, we wouldn't know what the bad guy had done. So we're going to go ahead and use the exclamation point as a placeholder. And we're going to go ahead and delete that, that sigma. So we have changed the first letter from sigma to this exclamation point. We're using the exclamation point as a placeholder because we don't know what the original one was. Now we can go ahead and we can go ahead and see if we've created any problems. So we're going to go Alt-Object again, and we're going to read the directory again. It says changes have been made to cluster 395, and that's where directory 1 is, and we're going to say yes, we know that. We want to hit a W to write it, and then we're going to go reread it, and it comes back and it doesn't have any errors. It has now found it. And in fact, if we go Alt-X to get out of this and we do a directory, now we'll see that we have that file of the exclamation point ile2.txt. You now have all the skills that you need in order to recover deleted files from DOS or FAT file systems. The only tricky part that you're going to have is when you have files that are longer than a single cluster, you're going to have to what you call chain them together, and you're going to have to determine if they are in sequence. And we will give you an exercise to do that, and that's what your lab is going to be about. But I encourage you to go through and redo what I've done here in the video, utilizing the Lab 2 worksheet that you will be able to download from the Learning Management System. So that's all there is for this particular video. And until next time, have a good day. Okay, well, we're going to be done with our WinHex, disk editor for right now. So we're going to go ahead and go Alt-X, and that will exit from the program, and that'll take us back to our DOS prompt. Okay, so we took a look at the files that we had before, and we see what's on there. Now we're going to go ahead and we're going to create an additional file. And we're going to use a really old style way. We're going to basically copy some text via the console to a file. Some of you that have done some Unix stuff, that's a very common thing. It's been a long time since it's been done in the Windows community, but for the purposes of this exercise, we're going to do it. So I'm going to create a new file on the A drive. It's going to be called File1. So it's got A colon. First of all, I have to get my cursor in here. So I'm going to go ahead and do the copy con, which means copy from the console my A colon and then slash file1.txt, and then I'm going to hit enter. And now anything that I type is going to be saved to the file once I give it the Control Z. So I'm going to go ahead and type this is file 1, and then I'm going to hold the Control key down and Z, and then hit enter, and it says one file copied. So if I do a directory of A, I will now see, in addition to the command com there, I will see this file1.txt. And if I were to type that out, which is the term in DOS for printing or listing, it would show this is file 1. Now I'm going to create a directory. Okay, and so my the way that you do that in DOS is the MD command. So it's MD A colon and then slash, and I'm going to call this dir in caps, dir1. Okay, and hit enter. Okay, and so if I do a directory again, I will now see that I have two files and I have a directory. I am going to put a file in that directory, and I'm going to use the same method as I did before, copy con, A colon, only this time we can put dir1 slash, and we're going to call this file2.txt. And I'm going to hit enter, and I'm going to put this is file2. And then Control Z to end the input, and then enter to save it. All right. So now if I do a directory and I use directory A and I use the /s, that will go down and iterate through the subdirectories. And so if I do that and hit enter, we'll see the root directory there with command com file1 and directory 1, and then in directory 1 I have 3 entries. I have 2 directories, a dot and a dot dot, and a file2.txt. It says there's a total of 6 files there. Well, wait a minute, there's only 3 files if you count command com. Well, they count the directories, including the dot and the dot dot directories, as files, and you'll understand a little bit later why, but they do. And so we have created some files on here. So we're going to crank our disketted back up, and disketted A, and open it up and say, okay, yeah, I get that. And it brings us up to the root directory, and you can see there the listing of the files, including the hidden ones. But now you have, in addition to the Lab2 volume, you've got file 1, which is the text file, and then you have the directory, which you'll notice over there with the flags is flagged as a directory, so that gives us a little idea of where we're going here. Now, if we were to go ahead and move our cursor down to file 1 and hit enter, right, we'll get a hex view of that file. Now in this particular case, because we haven't been using the DOS machine to do very much, there is just unallocated space below that. You can see all the zeros. If we had been using the DOS machine to do a bunch of things, we would end up with some likely looking gibberish below that, and that's the RAM slack. But we'll see an example of that a little bit later on. Now, if we go back up to Alt-O and we go to our directory, and we come down here to the directory 1 and hit enter. Now what we're looking at here is the directory listing for the directory dir1, and we can see the dot and the dot dot entries as well as the file2.txt. And you can see that the dot entry and the dot dot entry are both listed as directories, and they're flagged as such in the attributes on the far right side. You can see that both of them are 0-byte files, right? But they have a starting cluster, in the case of the dot file, of 395. Now, if we look down at the bottom right, we will realize that we're in cluster 395. So what this is essentially telling us is that a directory is a special purpose file. It's a file entry just like the file2.txt, but it's marked as a directory in its attributes. It points to itself, this cluster, right, 395, which is where we're actually at, and it's a 0-byte because it doesn't actually have a file associated with it. There's no data associated with this. Conversely, when we get down to the next one down, which is the file2 the double dot, same deal. It's a directory, 0 bytes, but it points to cluster 0. Well, if we remember, cluster 0 is the root directory. So what the dot and the dot dot do is that they essentially tell a directory where their root, where their parent is. In this case, the root directory of cluster 1, the parent of it, in other words, is at cluster 0. And that it knows where it is because it has the dot entry. So it can find itself at each layer. And this is a technique that DOS uses throughout its subdirectory structure. Now you'll also notice that in the case of file 2, it starts at cluster 396, which is the next one after this. And so we're going to go ahead and look at, and once you remember 396, we're going to go Alt Object, and we're going to go to the first FAT. And we're going to go down to the 395th and 396th offset. So we're going to go down and page down here. And as we go down here, you'll notice that at our cluster offset of 395, we have an end of file. And it tells us down here that that is directory 1. That's the directory listing for 1. And notice it's an end of file, meaning it has a beginning and an end. It doesn't go anywhere. It doesn't point to any other clusters because it doesn't actually occupy any clusters. The only thing that is in cluster 395 is the directory table, the directory, if you will, of that particular directory listing of that particular directory. And if we tab one over to 396, it will show us that that is actually the contents of file2.txt. And since it's only 14 bytes, it doesn't need to point to any other clusters, so it begins and ends there. So it's marked with an end of file. Now, we can go back up if we wanted to and look at cluster 396, but we've already done that. So I'm going to pause at this point before we move on to the next phase. Okay, so we're done for right now with Disk Editor again. So we're going to go ahead and we're going to go Alt-X to exit out of there to start the next phase of this exercise. Now we have one other area we need to look at before we get into some of the more nuts and bolts of this particular exercise. The first one, or the one I want to talk about, is the namesake of this file system, and that's the file allocation table. The file allocation table serves as the way the file system keeps track of where files are stored and how much space they occupy. And it's a structure that by convention, when the file system was developed, it was so important that they decided that they needed 2 copies of this, and these 2 copies have to stay in sync to make sure that we don't lose any data. So we're going to take a look at these structures. We're going to go Alt-Object, and we're going to go down here to the first FAT. Both the first and the second FAT file allocation table should be identical. Now, as you look at it, you see a bunch of numbers. You see columns and rows of numbers, and they seem to be somewhat sequential. Like you can see the very first one that's highlighted there is a 3, and then the one to its right is a 4, then a 5, and a 6, and so forth. You'll also notice that the one that are to the right and below the one that's highlighted are all in red, and we'll see what that means here in just a moment. But if you look down the very bottom, the Disk Editor tells us some good information. The first row in the gray area at the bottom here is known as the or it tells us what the particular unit is that's in the view. And so you can see where it says FAT first copy. So if it were the root directory, it would say root directory. If it would say the boot record, it would say that, etc. So it tells us where we're at in the disk structure. And then immediately below that, you will notice that it says the A:/IOSys. If you remember, IOSys was one of the files in there. So what it's saying is that this area here that's highlighted in red, all of these are part of the IOSys file. And you can see that that file occupies a number of these blocks here. And we'll explain how that works here in just a minute. Over on the right-hand side, it says that it's at sector 1, and it's at cluster 2, and the hex value is at 2. So the cluster number starts at 2, as you will see, because it's the first one is highlighted. And clusters are the allocation units. In the case of a floppy disk, the disk is divided into 512 byte sectors. But by convention in FAT12, sectors and clusters are the same size. So a sector and a cluster are synonymous in FAT12. They're not in virtually every other file system that we're going to look at later on. In most cases, they're multiples of 2. Most of the time, a cluster will be 2 or more sectors, usually 2, 4, 6, 8, 16, 32, 64, etc. They are allocation units. So a cluster is an allocation unit, whereas a sector is a physical space of 512 bytes. But as I say, by convention in a floppy disk, or anything that has FAT12 as the file system, a cluster and a sector are the same size. So in this case, cluster number 2 has 512 bytes because it's only one sector. And you can see that these sectors seem to be numbered. Well, as you look down below where it says cluster 2, right, but it has the number 3 in it. Well, what that means is the next cluster that forms this file is located in cluster 3. So it starts in cluster 2 and it continues to cluster 3, and then in turn it'll go to 4 and then to 5 and then to 6, so forth, until it gets to the end of the file, which we're going to see is actually going to be cluster 81. Now 81 is, the number 81 is here, but that's actually cluster number 80. So it is a pointer. 2, as we can see, this is cluster 2, points to 3, 3 points to 4, 4 points to 5, 5 points to 6, until we get to the end of the file. Then we're going to see down here at cluster 83, or correction, at cluster 82, that another file is going to start. And so let's go ahead and do that now. I can go ahead and move it down. You can see that the label down at the bottom is still an IOSys, and then all of a sudden I get down here and it says, oh no, this now MS-DOS.sys. You can see that down here, right? And that we're in cluster 82. But cluster 82, as you can see, points to cluster 84, 82 points to 83, which it points to 84, 83 points to, 84 points to 85, and so forth. And this goes down until we reach the end of file, which in this case is going to be 156. And we'll show you that here. By the way, the tab key works well in getting it across. And then if we tab one more over, we can see that in 158, all right, that's part of command com. And so all of these are linked. Now when the files are in order, that makes it very easy. But sometimes we write a file and then we erase a file and then we write another file that occupies more space than the empty space that was vacated. And so parts of the file become disconnected. The file allocation table links these, so we could have one in theory that might start at 158, but then it might pick up at 225. And that's called a fragmented file. But the more a disk is used, the more common that is. So as we go through the file allocation table, we can see that all these things are linked together, and all of them show where they point to next. Now, once you get down to where there is no more data, you can see that there is a 0 there. And what that indicates is that that's not part of any file or any allocated space. It's just, it's available. It doesn't say it's empty. It merely says that it's available. If you delete a file, one of the things that you do is you put a 0 in every single cluster that that file previously was stored in order to make that area available for use by the operating system. Notice that you're making it available, you're not actually overwriting the data in those sectors. So that's the kind of quick and dirty on the file allocation table, and we're going to move into the next phase of our lab.